All right, folks, so here is the second video for solving and doing titration problems. So like I said, give me a second. Okay, so as I said, we're going to go through the 4 steps at how to solve a problem, and we're going to do a couple of them together. So hopefully you've got some paper, got something to write with to make this easier for yourself. Okay, so the 4 steps were kind of wordy on that little slide that you just watched, so we're going to shorten them just a little bit. Okay, so step 1 is write and balance the equation and label what's given. Okay, step 2 is going to be find moles of the known. And you're going to see here in just a second that it's super easy to figure out which one is your known. And we do that by doing moles equals M times L. And then step 3 is we're going to say change moles of known to moles of unknown. Okay, and that's going to be our little mole to mole problem. You'll see how ridiculously easy that's going to be. And then the last step is going to be find big M of the unknown. And that's M equals moles over liters. Okay, so you're going to see just how easy this is going to be. All right, so we are going to do a couple of example problems here. And here we go. Now, these example problems, if I was giving them to you in class or something like that, they would be word problems. And they'd be very wordy because there's a lot of information in them. But because we are not in class, and I'm trying to do this in a short video, I'm going to try to give you the basics. All right. So in example problem 1 here, we're going to take sodium hydroxide, which, Lord willing, I hope to goodness you know by now that that's a base because it has hydroxide, and hydrochloric acid. It's got acid in the name. You should know it's an acid. So we see here that we have a regular old base and a regular old acid. Okay, so step 1 is to write and balance the equation. So we know we're going to make water. Okay, you should remember from all the stuff about neutralization that we've looked at a couple of times now, when an acid and a base come together, they make water. It's what they do. And then you have the salt. Now, it is a double displacement, so sodium and hydrogen just swap with each other. That's where the water comes from. But just refreshing your memory, a salt comes from the cation, the positive of the base, and the anion, or the negative of the acid. So this one does actually make sodium chloride, table salt. Okay. Now this one, because this is our very first go at this, is already balanced. It's a 1 to 1 to 1 to 1. Everything's an understood coefficient of 1. We'll look at one here in a minute that is not that way. But like I said, because this is one that, we're just now trying, we're going to do a real simple one to start off with. Okay, so this particular problem says, in a titration of 5.0 times 10 to the negative 3 molar sodium hydroxide. So that's the first thing I'm going to label. Underneath sodium hydroxide, I'm going to write down that concentration, 5.0 times 10 to the negative 3 molar. That's the first piece of information given. It goes on to say it's titrated with hydrochloric acid of unknown concentration. Bam, there is my question mark. There's the thing that I'm going to be looking for. I do not know the concentration of hydrochloric acid. Okay. It says during this titration, it took 20 milliliters of sodium hydroxide. So I'm going to write that down. 20 milliliters of sodium hydroxide. Notice I put it with the other one because it goes with sodium hydroxide, to react with 10 milliliters of hydrochloric acid to reach the end point. And remember the end point, hopefully you watched the very short and rather kind of boring video yesterday. But, at least you got to see it. But the end point is supposed to be a very pale pink. Okay, so once they reach that end point, this is how much of each one of these it took to reach that pale pink. And we're being asked, I've already done my question mark, what's the concentration of the hydrochloric acid? Okay, now this stuff doesn't matter at this point. The reason we had to have this was to balance the equation. Okay, but in terms of the actual problem and doing the problem, it's not going to matter. Okay. All right, so we've done step 1. We have balanced the equation and we have labeled what we have. So step 2, find the moles of the known. This is my known. Why is this my known? Because it doesn't have a question mark. Okay, something that's unknown has a question mark. There's two pieces of information that you have to make something your known. You have to have the concentration and you have to have the volume. And I have both of those. Don't have it for this one, so this one's my known. Okay, so I'm going to write out my equation because we always start by writing out our equations. It's just what we do. Good practice. Okay, good habit to be in. Now we're going to go plug all this in. 5.0 times 10 to the minus third molar in for M. Now notice, remember, the big M equation uses liters. And in the problems, they always give you milliliters. And the reason for that is because of those burettes. Hopefully, as you saw in that little video, the burettes are like graduated cylinders. They measure in milliliters. So the problem is going to give you the units that your equipment uses, okay? But y'all, we know King Henry. We've known King Henry since August. King Henry died by drinking chocolate milk, okay? So we should still be able to change metric units. This is milli. It needs to go to liters. That's 3 spaces to the left. 1, 2, 3. Okay, so that's going to be 0.0200 sig figs. 1, 2, 3 sig figs on this because that's a 0 at the end of a number with a decimal. Liters. Okay, so now I'm going to get my handy little calculator here and I'm going to type that in. 5.0 times 10 to the negative 3 times 0.02. Okay. Now, technically, you could change that to scientific or you could leave it. It really doesn't matter at this point. But remember, when you multiply and divide, you go with the least number of sig figs. That's this one. This one has 2 sig figs. That one has 3. So we only need 2 significant figures here. So I'm going to scoot this over. And I know that has got a glare on you. Let's see. That's 0.0001, and I got to throw in another 0 to make it significant. Okay, 0.00010, and this is moles of sodium hydroxide. Okay, because that's the known. So this is step 1. We wrote and balanced the equation and we labeled it. This is step 2. We found the moles of the known. We had to find the moles of this one because it's the only one that had both of the pieces that we needed. Now we're going to go to step 3. And I may run out of room, but I usually just try to attach step 3 to step 2. We got to change the moles of the known to moles of the unknown, which is HCl. And this is that mole to mole stoichiometry problem. Okay, but it's real simple. I have moles of sodium hydroxide and I don't want it, so I put it on the bottom. I do want moles of the unknown, which is the HCl, and I put that on top. Okay, so moles of HCl is the unknown. That's what I'm looking for. Remember, this thing was called the mole ratio. This is the thing that changes one substance to another. And the values for a mole ratio come from the coefficients. Okay, and in this reaction, they're both 1. So this is a super, super easy one. I really don't have to do anything. Moles of sodium hydroxide cancel out because that's what our factor label table has it do. And I find out that there will also be 0.00010 moles of HCl. So now I know, remember, in neutralization, you have to have the amounts of the acid and the base. This is going to tell you the amounts of the acid and the base needed to make the water. And in this one, it was a 1-to-1 ratio, so they're the exact same thing. Okay, so here's step 1, write and balance the equation, label. Here's step 2, find the moles of the known. And then I just attach step 3 to it using that little mole ratio to change to the moles of my unknown. And then to finish it off, we're going to find big M of the unknown. Okay, so I'm done. These numbers, I'm done with them. I don't look at them again. Now I'm going to use the information that I have for HCl. Okay, so here's the moles we just figured out, 0.00010 moles of HCl. And then the volume. That's why I'm covering this up. I don't want it. I've used this number. You only use it once, so I don't look at it again. The volume I need is the volume for HCl because I'm dealing with HCl right now. So once again, I've got to change milliliters to liters. 1, 2, 3 to the left. So 0.0100 liters. Okay. And then all I got to do is crunch the numbers. Again, I'm dividing, so I go with the least number of sig figs, which is 2 because of that number right there. Remember, zeros in the front are placeholders. They don't count as significant. Zeros at the end, if there's a decimal, do count. See, we get sig figs review. Get so much good review here at the very end, to take care of this for us. All right, so I've divided my two numbers, and that should be my final answer. I've just got to make it out to two significant figures. So my final answer should be 0.010. Now, I don't know if you remember from chapter 13, back towards the beginning of March. But remember, with the big M equation, just like it was here, whatever you're solving for is also the unit. So because I was solving for big M is going to be my unit. And I'm going to put HCl on it. Okay? So that's my final answer. I had to do a few things to get there, but that is my final answer to this problem. Okay? The steps don't change. This is how every titration problem ever works. So now I have figured out what the concentration of my acid was that I didn't know to start out with. Okay? All right, let's try one more together. Okay, I know that my steps are way up here, but I got to scoot it up so I can actually write on it. So I'll go through the steps again as we go through the problem. Okay, here we go. So in this equation or this reaction, we have H2SO4, which is sulfuric acid, and it's going to be titrated with lithium hydroxide. So again, you should know, I'm gonna make me a little line here because that's bothering me. I want to know that that's done, and I don't need any of that stuff. All right, so here's sulfuric acid. Acid, we know it's an acid. Here's lithium hydroxide. Again, we should know that's a base because it's got hydroxide in it. All right, step one, write and balance the equation and label. Acid and a base, we know we're going to make water. An acid and a base makes water, is what it does. Then we've got to come up with the salt, the positive part of the base with the negative part of the acid. Here's lithium and here's sulfate. I got to check my charges. I should have mentioned that up above with the NaCl. Sodium was +1, chlorine was -1. So that's why it was NaCl. Now here, lithium is in group 1, so that's +1. Sulfate is -2. +1, -2, they don't cancel, got to cross. So that's going to be Li2SO4, lithium sulfate. Okay, with the salts, they are ionic, so you always do need to check the charges on them, but that's what that's going to be. Okay, we need to balance. Balancing practice, balancing, remembering metals first. Lithium's a metal, lithium's a metal. 2 here, 1 here. So I'm going to put a 2 in front. Then you can go to the polyatomic ions. I have 1 sulfate here and 1 sulfate here. Sulfate's good. It's done. Now I'm going to go on to hydrogen because we save hydrogen, oxygen to the end. I got 2 hydrogens plus 2 more hydrogens. 2 hydrogens plus 2 hydrogens. So that's a total of 4 hydrogens. So I'm going to have to put a 2 right there to get 4 hydrogens there. Now remember, I've already dealt with these. Don't have to recount them. But I have 2 extra oxygens and I have 2 extra oxygens. So those 2 2s got that balanced for us. Okay. Now for the labeling. The problem says by titration, 17.6 milliliters of sulfuric acid neutralized 27.4 milliliters of lithium hydroxide. And then it goes on to tell us what the concentration of the lithium hydroxide was. It tells us that the concentration of lithium hydroxide is 0.0165 m. Okay, so right there, we know which one is our known. This one has to be our known substance because we have both of the values for it. And the question goes on and says, what was the molarity of the acid solution? So we're looking for big M of the acid again, which is what we did in the first one. Okay, so there's step one, write and balance the equation, label what you've got. All right, step two, we want the moles of the known, which is this one. Okay, so I'm going to write my equation. I'm going to go plug everything in, 0.0165 m. Again, we have milliliters, so we need to change that to liters by moving the decimal place 1, 2, 3 spaces to the left. 0.0274 liters. Okay, now notice, remember, zeros in the beginning do not count as significant. They're placeholders. So we have 3 sig figs here, 3 sig figs here. So we're going to have 3 sig figs in our answer. So I'm going to go 0.0165 times 0.0274. And again, the numbers of moles are relatively small. But again, if you want to do that in scientific, you can. If you want to leave it like this, you can. I'm going to leave it like this. So I'm going to have 0.000452. Okay. And that is moles of that right there, lithium hydroxide. Okay, moles of lithium hydroxide. So there's step 2. Step 1, write and balance the equation, label it. Step 2, find the moles of the known. Okay. Step 3, change moles of the known to moles of the unknown. There's our little factor label table. There's our little mole to mole problem. I don't want moles of the lithium hydroxide because I already know that. I'm going to put it on the bottom. And now I've got to change it to moles of what I don't know, which is the sulfuric acid. Okay, that's our unknown that we're trying to solve for. Remember, this is our mole ratio, changes the substance. The numbers come from the coefficients. All right, so up here we have an understood 1. Right here we have a 2. So it's not a 1-to-1 on this one, but that's not a big deal. Moles cancel out. I'm going to take, well, let me type it in again, 0.000452. And all I got to do is divide it by 2. So that gives me 0.000226 moles of my unknown sulfuric acid. Okay, so there's, like I said, I like to tack step 3 onto step 2 just because it's real easy to do. So step 2 was find the moles of the known, and step 3 was find the moles of the unknown. All right, then all we got to do here at the end is wrap it up by finding big M molarity, the question mark, for sulfuric acid. Now remember, my known numbers, I'm done with them. I don't need those anymore. I've already used them. Everything I need is here and here. I need my stuff for sulfuric acid. So I'm just going to go and plug those in, 0.000226 moles over, okay, again, we've got milliliters. We need to change those to liters, 1, 2, 3 to the left. 0.0176 liters. 3 sig figs, 3 sig figs. So our answer is going to have 3 sig figs. My number's still there, thankfully. So now I just got to take my moles and divide it by 0.0176. And this should be my answer right here. I need 3 significant figures. Okay. So I've got 0.0. Now remember, I do have to write the 0.0. It's placeholder. It has to be there, but it's not significant. So I got to go 1, 2, 3 more digits. 0.0128. Okay, 0.0128. My unit is what I started with, which is M. And this is for the sulfuric acid right there. Okay. So those folks are titration problems. They follow the same 4 steps every time. All you have to be able to do is write and balance that equation, find the moles of your known, change the moles to the unknown, and find big M. It's the exact same 4 steps every single time. Okay, so the last thing that I'm going to have you do is just hop back over to Classroom. There is another Google Forms assignment where, again, like some of the previous ones have been, there'll be, I think, probably just one problem. Probably just have you do one problem. I may have it to where you have to give me your answer, to the different steps, but you'll see. You'll see when you get over there on that Google form. It's all multiple choice, but you will need your calculator and some scratch paper so you can get through the one problem that you're going to have there. All right. So, folks, that officially gets us through our final topic. Granted, there was a whole unit that we didn't get to go through, but, it's all right. It's all good. I appreciate you for hanging in here with me. Those of you who have been hanging in here with me, it's honestly, there's been more of you hanging in here with me than I really truly expected to. So if that is you, I thank you so much. I'm so sorry that this is how our year had to end. Truly, I am. And I just, I hate that I missed, these 2 months basically with you. I love getting to teach you. I love getting to teach you and help you learn new things that, someday you may need again or you may not. But, you're still going to be a better person for it, for having learned something new, whether you believe that now or not. But it's true, and it'll help you out later on as well. And, if you have any questions, shoot me an email, send me a message. Um, I'm sure I'll probably send one maybe parting message of some kind tomorrow, for those of you who want to listen to it. But there you go. So, like I said, just hop on over to Google Classroom, check out that Google form, and that will take care of what I have to teach you. Have a good one.